Okay, let's get started. It is so good to see everyone here. I know this has been a long 3-day journey, and it is great to be here. This is my first build. Anybody else have their first build out here? All right, I'm in good company. So, as an AI person, it's been an unbelievable experience for me. We have learned about the incredible power of the Azure cloud. We've learned about amazing breakthroughs in AI. And we have seen how easy it is to get started building your own intelligent apps and services. And it's almost time to get back to work and start building stuff. And when you do, I want to make you the case for why you should start using cognitive services. So I'm going to use my time today with me and some of my friends to be able to make the case for why you should. And so we'll start by talking about how dozens and dozens and dozens of customers are using cognitive services today. We'll talk about what we're learning from the field. And what's more, we'll hear from Symphony AI, which is an incredible new AI fund and startup incubator, which is building new AI experiences in a number of verticals. And then we'll learn more about what's next for cognitive services as we go forward. Between our enterprise experience and what we're doing for real customers today, and what other customers are building on cognitive services, I hope to make a compelling case for you all about why you should take cognitive services seriously when you're making choices about building your next app. So let's talk AI. And when I talk about AI, I'm not talking about this kind of AI. And I'm not talking about this kind of AI where we're ultimately having to build something from scratch. Yes, we can go to tutorials and we can go learn all about TensorFlow and we can remember our linear algebra, but there's got to be an easier way, right? And so I'm talking about pre-built AI. For pre-built AI, it's got to be performant. It's got to be customizable, right? AI is not one size fits all. We have to have the tools and tooling to be able to necessarily incorporate our domain expertise and domain knowledge into a service. It has to be compliant, right? If we're going to use this for real use cases and not toy problems, we have to understand what certifications we need. We have to take privacy seriously. We have to be able to look our customers in the eye and understand that we'll safeguard their data. You have to be in the cloud, that goes without saying, and it's increasingly important to be at the edge, whether that's an edge device like we learned about with the Vision AI toolkit that we saw in Satya's keynote on Monday, or it's on a mobile device, or it's on any new kinds of hardware that's being thought of today. And you have to be battle tested. It'd be nice to be loved by more than 1 million developers, but who's asking for something? And so obviously I'm talking about Azure Cognitive Services. And so Azure Cognitive Services, as you all know, is our collection of more than 25 intelligent APIs that run the gamut from speech and natural language understanding to computer vision to knowledge representation and reasoning and search. And it's been an incredible journey over the last 3 years. I am fortunate to work with people who, both in my direct team and in my partner teams, who've been there at the very beginning in terms of the Project Oxford days. And we were able, we started with a mission that's still our mission today, is to make it as easy as possible for anyone, regardless of their experience with AI, regardless of their skill level, to be able to incorporate the very best that Microsoft has to offer in AI into their apps experiences and services. And so we're still following up on that. We want to make AI available for every developer and no excuses. And so today we are following through on that promise that we started and the seeds that we planted 3 years ago. We are more enterprise ready than ever before. So I say there are 22 services that are in GA right now. That's 90% of the portfolio. And we're going to be trending towards 100% of the portfolio being in GA as we go towards the end of the calendar year. We're working hard to secure certifications, right? I know that people working in healthcare, and you'll hear from Symphony in a few minutes here about the work that they're doing in healthcare. HIPAA and HITRUST are paramount. ISO and SOC and BCDR and PCI, and if you're working with the government, those are the certifications there, are important in terms of building the experiences that you need to have, and we are guaranteeing that we will have that this calendar year. And later this month, GDPR has been a tremendous effort for us, and later this month, we will stand up and be able to say that all of the cognitive services are GDPR compliant. Most are GDPR compliant as data processors. And that means, that reflects our kind of understanding of the sacred trust that you have with your customers and that we have with you in terms of making sure that you're safeguarding and treating your customers' data as a sacred asset. And we're also increasing our investment in customizable cognitive services. So currently we have 7 customizable cognitive services. You have seen computer vision if you spend any time on the floor. In terms of custom vision, we'll show a little bit of an example of some of the work that you can do there. You may have heard of custom speech and custom voice, part of the new integrated speech API that we rolled out this week. So custom speech allows you to be able to build custom acoustic models or custom speaker models. Custom voice lets you build the incredible your own text-to-speech font given a couple hours of recorded speech. And it gets better, both of these, all of these services get better with the amount of care and feeding that you provide them with and how much data you ultimately offer. Custom translator, in the old days you had to provide bilingual corpora to be able to, or bilingual aligned corpora to be able to improve the quality of your translation. Now you can do that with monolingual corpora and be able to bring the quality of translation to your specific domain and the vocabularies that you and your customers use. Language understanding is the core of many of the bots that we build. And in terms of being able to use supervised learning or semi-supervised learning to be able to build intent classification that will allow you to be able to understand what your customers are saying to your bots. Custom search is one of my favorite services. It allows you to build custom search appliances and ultimately modify the relevance ranking such that you can actually get the best results that are tailored to your domain. And last but not least, definitely not least, is Content Moderator, which allows us to be able to keep our workplaces and our children safe from explicit and offensive content, and it is customizable to the demands and changing demands of a very dangerous and treacherous internet environment. So I'm going to spend a little bit before I hand it over to some of my friends, talking about why customization should be something that you can't live without. Customization is the superpower which allows cognitive services to be enterprise ready. So when we talked about the 7 customizable cognitive services, I talked a little bit about performance. Right? I want to make sure that my custom speech model understands me, or it understands my 6-year-old, whom you'll see in a few seconds, who has a lovely voice, but not one as you normally train for ASR systems. So how do you get the performance you need? You can use customizable services like custom speech and custom voice to be able to titrate in more data and to be able to rebuild your models to be able to tailor them to your specific performance applications. So here's an example, and I won't play it for you today, but it's a transcript of 2 different versions of our speech recognition algorithm for calls made by currency traders, right? And they're using custom vocabulary, right? It's a GBP. Right? Or they're talking about specific order numbers. And if you look on the left, the baseline, you're using the kind of default ASR. Now, it's pretty good. It's intelligible. But it doesn't reflect the custom vocabulary that the trader actually used. The one on the right, which was trained with a specific model based on the kinds of exchanges the currency traders ultimately had, does far much better. And we can actually cascade this for things like our speech-to-speech translation models. So custom speech, so for a speech-to-speech translation, you're taking speech in from a foreign language, you're running it through automatic speech transcription, you're bringing that back to a translation model, which is doing text-to-text translation, then you're taking the text out of the other side, and then bringing that through text-to-speech and back out to something that somebody can hear. And so custom speech works in conjunction with custom translator and custom voice to be able to get you to make sure that you have the performance that you're ultimately looking for. And we have a customer today who's using this for a healthcare setting. And so you go into an ER and you speak a language that none of the healthcare staff actually speaks. You can actually use custom translator and custom speech and custom voice together to be able to have a conversation, translate the conversation you're having with a patient, so you're not necessarily at the most critical time fumbling over words. So the next thing you can do is focus on solving your problem. I talk to a lot of customers as part of my job, and they, at some point they have an initial burst of enthusiasm. And they say, "Wow, these cognitive services are great," and then they come back and say, "Well, but you don't understand. My problem is very, very hard, very, very difficult, and I don't think that the state of the art in AI has gotten to the point where anybody can understand my problem." And I say, usually look at them and I listen, and then I say, "Try me." Because the cognitive service that we have and the customization framework that we have is often so powerful that we can actually make a dent into the problem. So to be concrete, this is a real world, real life problem. The kind of protagonist of the kind of event here is, on the left is my 6-year-old daughter, Mira. She is an inspiring AI developer, a Minecraft fan. She likes Python because she likes snakes. And so I'm not sure what she thinks about Go or C# at this point, but she's definitely into Python. She has a brand new garden that she planted in our backyard in Pine Lake. And our backyard also has is home to a family of, count them, 6 pesky varmints, white-tailed deer, that would love nothing more than to eat her greens. And so the other night she made this appeal to me, and I had to. It tore my heart out to the point where I had to record it.
Hi, it's Mira. Daddy, the deer are eating my garden. Can you use AI to fix it?
Well, yes, Mira, yes, we can. And so I said, well, you really want to use AI? And she said, yes, that's all that you talk about, Daddy, at home. And I said, okay, fine. And so we took her to CustomVision.ai, which is the portal that we use for our Custom Vision service. And we used another cognitive service, Bing Image Service, and we downloaded Image Search, and we downloaded about 500 pictures of deer eating grass. Now, keyword interpretation has gotten so good with Bing that actually a query like deer eating grass actually can bring back meaningful results. And I set her up on her iPad, and I had her annotate all the images of deer. And she said, okay, good, I'm done, after she annotated about 500. And I said, no, you actually have to recognize the actual images, the objects that are of the bounding boxes corresponding to each of the deer as well. And she said, she looked at me and she rolled her eyes and she goes, and this is all for my garden. I'm really interested in doing this. True story. I couldn't make this up. And so she used the Custom Vision AI portal with object recognition, and she was able to draw the bounding boxes around each of the deer. And then she was able to deploy the model. And she asked me whether 97% was pretty good. And I said, I assured her that it was. And then I had to step in because she wanted to be able to put it on her iPad and be able to take it out in the yard. And be able to see if the model worked. And luckily for us, Custom Vision supports export of these custom trained models out to a variety of formats, including ONNX, including a Docker container, including TensorFlow, and lucky for us, CoreML. And I was able to take the model, wrap it in a Xamarin app, and be able to put it on her iPad and kick her out the door and have her spend some time in the yard going after deer. She saw Satya's keynote on Monday, and she is very interested in me bringing home a Custom Vision AI kit, the Qualcomm camera that we built. I am not sure I can get my hands on one, but I am sure going to try. So the third thing that customization is really good for is in terms of making an experience uniquely yours. And so we talked about custom voice, and this is an experience that I love in terms of if you can give me some recordings of your voice, you can go to the Custom Voice portal, and you can build a custom voice font that you can deploy. And so no more relying on generic voices that you've heard a million times. No more having your customer experience sound like Cortana or Siri or Alexa. You can actually own this and make this sound like you. And the thing that I love about this,
you can get started with just a few dozens of recorded sentences.
Yes, right. And you can get started with a few dozen recorded sentences. And this one's about 500 recorded sentences. Here's one about 6,000 recorded sentences, and you can see that the voice is a little bit better in terms of its prosody and kind of.
You can create your own branded TTS voice with Microsoft Custom Voice offerings.
And so the interesting thing here is that you can build an entire custom experience from speech to speech through translation without having to write a line of code. Right, so we're trying to, not only are we enterprise ready, we're knocking down the excuses you have in terms of actually getting started with these kinds of experiences. So the tagline that I will leave you here with is that customization and pre-built AI allows you to get to market faster with AI that puts you in control. No more kind of waiting on making sure that you can hire a data scientist. No more waiting on understanding, getting through that TensorFlow tutorial or that CNTK tutorial. We have tools that are available and ready to go now and are being used by dozens and dozens of enterprise customers. And as we grow our customer base, we are learning tremendous amounts about the way customers are using our AI in their enterprise applications. And I could spend all day. In fact, I think in the early draft of my talk, I basically wanted to talk through this matrix and talk about exactly all the different ways people are using cognitive services. And then I was told that it would not be as entertaining as some other things I could do. But we're going to talk about 2 use cases. We're going to talk about predictive maintenance, which many of you are familiar with in terms of understanding defects, being able to predict and understand the root causes of defects. And then we're going to talk about business process automation, which is a fancy way of saying using cognitive services and other kinds of associated reasoning technologies to be able to automate the kinds of things that we do online today. So In between here, I will actually shout out and show you some interesting technologies that are built by other folks not on my team that we are fortunate enough to work with. And so I will cede the mic here and I'll let you see demos of interesting technologies that have kind of advanced the state of the art in terms of predictive maintenance and in terms of BPA. So we are working with customers all across the industrial sector in predictive maintenance, whether it's automotive and aerospace. Autospace would be something, I'd need my flying car. Oil and gas and energy and different kinds of manufacturing. And so, really predictive maintenance systems offer three kinds of benefits, really in terms of safety, cost, and efficiency. And let's take a look at the use cases themselves in terms of how we actually can recoup these for your enterprise. So anomaly detection often leverages computer vision system or cognitive services like computer vision to be able to recognize failures before they occur. And so you can imagine that whether you're trying to monitor your workplace and make sure that your employees are complying with OSHA guidelines, or you're necessarily trying to point a camera at a piece of equipment and trying to understand how its performance changes over time, cognitive services provide you a great way of being able to kind of gather the data that you need to be able to make a real-time inference. Root cause analysis, right? So once something fails, can we actually look at all of the kind of multimodal kind of data that hangs off that event and be able to try to explain things why they've ultimately happened? Now, we don't have a root cause analysis service. We don't have a prediction service in cognitive services today. But ultimately, we offer in Azure capabilities that would allow you to build those kinds of services based on the kinds of raw material that you're bringing in from your multimodal channels with cognitive services. Expert finding. So things like, if you've worked at any time in a software development environment, you know the situation where we wake up on Monday morning and your whole entire development team has filed bugs on the same issue, the same defect, right? And you wake up and as a PM, you wake up in the morning and you've got 50 bugs filed on the same issue, and you have to understand, well, are there really 50 issues or are there one issue? And ultimately, if there's really only one, who do I assign it to? Because who ultimately caused that problem? So something like text analytics allows us to be able to do that kind of conceptual understanding. And then services like prediction services that you can build in things like Azure Machine Learning would allow you to be able to classify those errors and ultimately find the right person. And so just to kind of give a concrete example, we work with an aerospace manufacturer who has a complex situation, a kind of complex scenario built where they're bringing in real-time telemetry data. They're passing it through an Azure Event Hub. And they're passing that to Azure Stream Analytics that are decorated by cognitive services. And so we're using custom vision and computer vision. We're using our video analysis capabilities in Video Indexer. And we're making all of this available in a search interface powered by Azure Search called Cognitive Search, which if you haven't checked it out, it's a wonderful thing, and it's just been announced this week at Build. And you can actually use all of the cognitive services in conjunction with a search appliance to be able to quickly annotate large amounts of information, whether it's in video or text or audio or transcripts or OCR documents, you name it, we can crack those documents and make it available with a single call via an API. And so ultimately what we're doing is we're taking that stream analytics and we're storing that data such that you can actually infer about it going forward. You can actually look at, to tie custom policies and actions for that. And then you can actually pass it to a Powered BI dashboard to understand what ultimately is happening in your shop. So if we kind of continue with the shop metaphor for a second, we're going to talk a little bit, I'm going to actually turn the floor over to Ravi Yada, and he can talk a little bit about one of our cognitive services, which is Bing Visual Search, which is one of my favorite cognitive services because it combines the power of the knowledge that is stored in a global search engine like Bing with the ability to kind of process images and understand them in a meaningful fashion. And so what I really like about Bing Visual Search for a factory context is that we can actually, whether it's pointing a camera at a part on the floor and trying to understand where the hell that came from, or pointing you can imagine pointing the camera at a problematic situation and trying to understand that. Bing Visual Search provides you a framework to be able to build those skills.
Thanks, Andy. So I'll be talking about Bing Visual Search. So to start off, I'll start with the video. I think that'll kind of summarize my presentation, so it'll be less work for me. Cool. That was pretty much summarizes my presentation, but let me go a little more in detail. So this basically covered three main things. The first thing it covered was the Bing Visual Search, what visual search is, being able to take a picture of something and learning more, or understanding more about the world around you through image as input. Second thing it talked about was we're announcing this as an API, so you as developers, enterprises, and consumers can get this API, use it in your products and services to improve and provide this image-based search capability into your products. Then the third thing it talked about is the Visual Search Developer Platform. So this is something new. We haven't seen this in the industry. It's something new we are announcing at Build this week. And what it is the ability for you to extend the capabilities of our visual search and customize it for your own needs. So as you might have seen throughout Build, we have shown that we have a lot of visual search capabilities, like some things you saw in the video, like recognizing animals, plants, recognizing people, landmarks, and so forth. So we've been using these visual search capabilities to provide a first-class experience for what we call our visual search users who want to learn about the world in a different way. And what we also notice is that enterprises, developers, and others have also computer vision models, have their own set of unique data that would help these visual search users, but have no way to connect to these folks. So that's why we announced our Visual Search Developer Platform to bridge this gap and allow you to take advantage of our visual search capabilities and get an audience with our visual search users. So, the best way to do this is actually, I'm going to switch over to my laptop to do a live demo of building a skill. So to build a skill, you go to bingvisualsearch.com, and here we provide information. All the stuff I'm talking about is provided here. We have documentation and step-by-step process on how to build skills, and a quick start guide that has sample code and everything to get you started. But let me go ahead and actually build a skill. And the skill I'm going to build is something that you can kind of use internally in your company, or maybe use with the end consumer. So a user is able to take a picture of a product and maybe learn more information about that product through your company portal. So for example, you can imagine it's a picture of a pair of headphones and they're broken. And you as a company can provide details on how to fix it or provide a replacement and things like that. So I'm going to click Create New Skill here. And I'm going to call it Store Search. And it's going to find products in the Microsoft Store. So the next part in building a skill is actually 3 simple steps. The first step in configuring your skill is deciding when your skill should actually trigger. So you might have seen this in voice assistant skills where you have to kind of invoke by saying the name of the skill. Here it's slightly different. It's based on what we call our visual intent. Visual intent is kind of defined as what is the most likely intent of this image based on the content in the image itself. So we have a set of custom visual intent triggers that you can choose from for a set of base categories. We're always working on improving and extending these categories and triggers. So if you have suggestions, please feel to provide it to me or through our feedback and support. For this case, I'm just going to choose to trigger my skill all the time. And then the second thing is you want to decide what data do you want from the Bing Visual Search capabilities to be sent to you. So for example, we'll by default send you the visual intent that tells you why we triggered your scenario. And then you can also ask for things like annotations that describe what's in the image. So you do not have to build your own computer vision recognition model to recognize. But in the future, we're allowing you to extend these by building your own custom vision model if there is a need for it. And then you can also take the raw image right now. So if you want to run your own processing, you can as well on the image. And we also detect various objects in the image like fashion and clothing. So you can also leverage those. And then we also provide OCR text that's on the image, and you can use that to understand more about the product that you took a picture of. And then the third thing is actually providing a service URL of where your code is actually hosted. So for this, I've been kind of doing this in Azure as an Azure function because it's a simple HTTP request that I can make. So I'm just going to quickly save this and explain what this Azure function is doing. So the actual code that I have is actually less than 100 lines. But here's a summary view. So this view is just removing all the comments, removing all the error handling. So don't code this way. But this is like the simple view, and it's less than 35 lines. And what it's doing here is parsing the annotations that I've configured in my skill to leverage. And then based on that, it's making a request to the Microsoft Store page with the product that I recognized, and then providing back a skill response that's a format that we provide in our documentation. And that's basically it. So while I was talking, it saved this, and now I can actually start testing my skill. So I'm going to upload a picture. I'm going to upload 2 pictures here. So one is this picture of this Forza, the video game. So it's going to start generating the image metadata. So this is the JSON response that's being sent to your endpoint of your skill. So you can use this to debug and understand what exactly is being passed. And then what you can do after that is actually click run. Oops, I think. Let's wait for it to load again. There we go. And then you can click run, and here it actually hits your endpoint. So this is based on the response that I have in my code. So, and then it also provides a little preview. So for example, it provided a little preview text that says search Microsoft Store for Forza. So it recognized based on the cover of that video game that this is the Forza video game. And now clicking on this link will actually take me to the Microsoft Store to learn more about Forza. So you can imagine this, replace this with your own product, replace this with your own type of scenario where you're linking users from the real world products that you provide, either on internally or to your end consumers, and then providing them knowledge and actions based on it. And we also are allowing you to simply test this on your mobile device as well. So with the latest update to the Bing iOS app, you can actually download and enable camera skills. And with this following test code, for example, you can run your skill that you made in this portal on your mobile device. So it's a quick way for you to test and take pictures of real world things and fine-tune your model. With that, that's kind of it on how to build a skill. So I'm going to hand it back over to Andy.
So one of the things that we hear from our enterprise customers all the time is that they're looking for new ways to be able to capture data from a factory setting or an industrial setting. And so with that, I'm going to bring Kyle Beck up, who's going to talk a little bit about Project Ink Analysis, which is the new cognitive service made available in the Cognitive Services Labs that uses the power of Windows Ink to be able to capture data. Thanks, Kyle.
Thanks, Andy. Okay. Yeah, so I'm Kyle, and I'd like to talk with you a bit today about ink. And stepping back a sec, why do we care about ink? Well, take a look at the things that are on this slide. Ink allows you to record your thoughts in ways that no other input can. So I've got things here like sketches, or kind of a circuit diagram, or physics notes, or a to-do list here that's done in a very personal style to me. And these are great expressions of how the pen, as a tool, allows you to make these very creative and expressive thoughts, record those down. We also think, though, the pen is a great tool for productivity, especially when we pair it with AI. And that's the main thing I want to talk with you about now. If you've been following Windows Ink, you'll know that we already have a rich platform of Windows APIs that allow you to easily add an ink experience into your app. Today I'm going to focus here on the block on the left-hand side, the right-hand side there, which is ink analysis. And these are the APIs that allow you to actually understand the ink that a user has created inside your application. Now, these have been available in Windows locally as part of the last couple releases, both as UWP and Win32 APIs. But we know a lot of you are making applications outside of Windows, whether it's iOS, Android, or web-based apps. So we're happy to announce that we are moving these APIs up to the cloud as Project Ink Analysis, which is a new Cognitive Services Lab that we just announced on Monday. And now I'm going to give you a quick demo of what this allows you to do inside your apps. Give me a second here to wake this up, and then I'll switch over. Okay, So what I have here is an ink canvas. It's using one of the platform pieces that I showed on the previous slide. And what it's going to do here is it has a timer that's listening for me to stop entering an ink stroke. And then after a little bit of a delay, it's going to go hit our service to actually do the recognition call. So I'm going to draw a simple shape here. So it's just a triangle. And there's a little status text up in the top that said, hey, the analysis ran and it completed. When I tap on it, I'm getting some UI here. And this UI is an indication that we've actually recognized something. But what did I send up, and what did we actually get back, and how can you kind of use that inside your apps? So the request here, it looks a little intimidating, but it really isn't. What you're sending up is a representation of the strokes that are on the screen. In this case, it's just a single ink stroke, and this big blob of numbers here are the XY coordinates of the points that actually make up that stroke. If you're using our platform, this is the exact same information that you would get out of the Inkstroke class, so I just serialized that and sent that as part of my request up to the service. What you get back is a set of essentially recognition units. The local APIs, these are the nodes that you would get out of ink analysis. And what these are is they break down the ink and they tell you what we actually recognize there. In this case, we understand that this is a drawing. Sorry. Okay, not letting me select there, but you can see it's a drawing. In particular, it is a right triangle. You get some additional information up at the top here. You get a bounding rectangle. And this is the coordinates where basically you can draw that bounding rect, and all the ink that you just sent up lives inside there. So it gives you kind of some spatial information. At the bottom here, you see another set of points. And I'll show you in a second what you can use those for. But those are where it allow you to actually take that ink and then transform it into actually the actual perfect version of what that shape was. And the other thing that's in here, sort of in the middle, you'll see that the class here is a leaf. So I'll show you this in a little bit when I add some more ink onto this, but we return a tree structure to actually allow you to understand the layout of the whole document that you're sending up. And I'll give you some examples of what you can use that for. So now I'm going to go back here, I'll tap on it. That little button there is going to allow me to use those points and beautify the shape. So when I tap on that, I just converted it. Now it's that perfect triangle. So I'll send it back to ink, and now I'm going to do a little handwriting. So there's my sloppy writing. Again, we analyzed it. I can tap on it, and we're getting the recognition results for my handwriting. The request, again, is the exact same thing, where it's just the series of strokes that are being sent up. Now I have a few more of them to represent the letters that were in the word writing. The response, again, I have my drawing up at the top. But if I scroll down, now you're seeing some additional things. So we get an ink word coming back. We get the recognized text, which is the word writing. This also has a bounding rectangle. So this, again, allows you to do kind of layout analysis and understand where things are on the screen. Above that, you'll also see alternates for what the recognition could have been. And this will be a sorted list for you kind of in decreasing order of probability for what that may have been. But the recognized text here is always the top result. So like I said, this comes back in a tree. And this is just a tool that we wrote that kind of visualizes that tree. So under the root, you'll have your shape there, which is the right triangle. And then you have a writing region. Underneath that is the paragraph. Underneath that is a line. And then underneath that is the word writing. And that was actually in the response here. If I scroll down just a little further, you'll see the line coming in, a paragraph, and a writing region. Those also, again, all have bounding regions on them. So that's a simple example. If I want to load up some more ink here, so there's some additional things inside here. The tree of the response is a little more complicated now, but it has those same basic structures in it. It has a number of shapes. It has a couple writing regions here. The paragraphs. Now you also see list items appearing. And what these are is when we recognize a few lines in a row that have a bullet in front of them, instead of just telling you this is a line of text, we'll also tell you this is a list item. So through using that layout analysis that we have, I can tap and select a word, and I'm going to double tap on that word, and it's going to go up the tree. So the parent of that tree was this line, and if I double tap that, now I have the entire list selected. And if I double tap again, I can't go up any higher because we know that's the end of that list. Even though I have additional text up at the top, that Microsoft Project Ink analysis, we know that's not associated with the list, so we don't go up and select that. What this allows you to do is with that layout information, those bounding rectangles, you can do things like, well, beautify the ink that you have there. I wrote this list. I meant for everything to be left aligned in it, but I sort of messed up in the middle ones, kind of floating off on the right-hand side a little bit. So I'm going to hit this button on the right, and it's going to left align everything in the list while leaving it as my ink. And that's just using that bounding information that you got back from the recognition call. Now, of course, if you wanted, you can come along and convert the whole thing into text. On our team, we really like the expressiveness as ink. So we think about scenarios both where you want to convert things like this, and also the kind of scenarios where you want to leave it as ink, but still add some kind of intelligence on it, like doing that sort of beautification or understanding what the content is. And another example of understanding the content, I want to be able to search this. I want to be able to get back to the things that I wrote as handwriting, but leave it as my handwriting so it's still expressive. So I can go along here. I'll type the word ink, tap it, and now you see we understand what node that was, so we can go find that node and just change the ink color of it. And now we understand, okay, yep, you actually wrote ink, and it's sitting right there. So that is the quick view into what you get out of the service. And really, those are kind of our initial thoughts on it, and we're very excited to see what you can think of to go use this for. So please reach out to us, whether you have questions on how to use it, feature requests, or just general thoughts about ink. Our alias is windowsinc@microsoft.com, and we would absolutely love to see you use it and get your thoughts on it. So. Thanks.
So we talked a little bit about business process automation before, in terms of being able to use cognitive services and other AI-related capabilities to do things like automate data capture. Windows Ink and Project Ink Analysis is a great example of that. But you can imagine, I was sitting there watching Kyle's demo and thinking about how we could actually use things like text analytics or computer vision to be able to even augment further the kinds of annotations that you're able to capture through Ink. So form filling or document processing is a natural place. You can imagine if you had a service that could look at claims documents from whether it's a health record or whether it's an insurance claim, and understand whether you're actually putting the date in the right field or signing at the right place. We have customers who are actually using this now to actually process mortgage applications for the dozens of times you have to sign to make sure that everyone's signed in all the right places. And so in terms of workflow automation or claims processing, we have dozens of customers now at this point who are using combinations of cognitive services to be able to make that happen. So rather than talk about some of our use cases, I'm going to invite Sanjeev Jagtap to come up and talk about one of the kinds of workflows that is nearest and dearest to the cognitive services family heart is in terms of customization for content moderation. And so the internet, it can be a scary place, and what Sanjeev and his team are ultimately able to do is make it a little bit safer for our children and our workplaces.
Okay.
Not yet. Okay, what happened? Hello? No? Oh, I see. Okay, that's good. I'm part of a team called Risk and Protection Services, and I'm representing a product called Content Moderator. And so this team is kind of unique and at Microsoft, where our mission, our mandate is to protect Microsoft against the bad actors, the bad content, right? The criminal activities such as theft of IP, licensing abuse, and also counterfeit products and so on. And so out of that work done over the years has emerged this cognitive service, which is called Content Moderator. Some of my colleagues are sitting here, and that's what I'll be talking about, right? So the scenario. So think about this. I guess the thing to compare our team is that normally all the sessions here are talking about how to find the next haystack, I guess, to work at. What we are doing in our service, with our service, is finding those needles in those haystack, right? And those haystacks are growing, as we know, thanks to UGC and content and internet. And so that's the scenario that we are trying to nail by making sure the goodness rises up faster. So the scenario and the demo that I had, just to convey kind of what kind of possibilities exist in this space are that imagine that you're an online marketplace and you have manufacturers uploading products to your website, and you're looking to moderate content for offensive content, as well as kind of investigating suspicious listings, which could be perhaps counterfeit products, all right, coming up being listed when they should not be. And so what are the requirements? The requirements are scan catalogs for potentially illegal and offensive content, and then also match that content against, or those catalog against maybe confidential product images or codes that should not be online. And if they are online, well, that's an indication that there is something else going on there and that we need to investigate. And the third requirement is, of course, how do we automate this end-to-end workflow of content ingestion, scanning, taking the insights from these APIs, comparing it against your content thresholds and policies, bubbling it up in a human review tool, and then finally, after those decisions are made, submit the data back into perhaps another investigation system or your own in-house tools. And so the solution that I'm talking about in the demo is using Content Moderator from Cognitive Services primarily. And we'll see in a minute how that works. And so what matters most in these cases is, of course, increasing speed and reducing cost of filtering out the bad content, as well as using customized AI-based processes to augment human review and loop in the process. So in our case, we especially believe that AI augments the human review process, and then when you combine them together, you get the best results, especially in complex, nuanced cases like these, right? So what is Content Moderator? It's a platform, and you might think this is a collection of services, which it is, but it's the Content Moderator itself is one cognitive service that has this collection of APIs to scan your text, image, video for illegal, explicit, suggestive, and offensive content, right? So that's the bottommost layer. On top of that is something we call a review API, which is the bridge to connect your API insights to a human-in-the-loop process. And so the review API consists of workflows to automate those life cycles, jobs, which are really end-to-end asynchronous processes to scan and create human reviews, and the review operation, which is really just to create plain old reviews in the review tool. The flexibility you get as a result is that you can bring your own APIs, you can use the different cognitive service, doesn't matter, but you can still get the built-in, out-of-the-box review experience with the service. And of course, you have these moderators sitting at the top using the UI. These could be either your employees or an outsourced vendor or even crowdsourced companies. Right. So the demo I put together just for this is a very simple, specific, narrow scenario, which takes some sample content, right? And the first problem, remember, is to classify it and detect offensiveness. The second problem was to match it against known data, known content, right? So you're really looking for exact matches here. And the third is you could be using a custom vision service, for example, to custom classify and look for custom patterns in your data, right? So in the demo that we'll see, what happens is the classify and then the match steps, they trigger a job process or a job step, which are being driven by workflows that we'll look at. And these workflows are the ones that are actually taking these scanned outputs or the insights from the APIs, applying your content policies and thresholds and criteria, and then defining whether to do an action, such as in our case, create a human review, right? And the custom classification in this case, I did comment out the code in my demo, just in the interest of time. But in this case, the code actually creates the human review directly based on the custom logic in the application code itself. In both of these cases, the job, whether you call the job API or the review API, what you get is a human reviews of your images, text, and even videos in an online review tool that Content Moderator includes by default. And so when customers are signing up for our service through Azure, they're getting not just the APIs, but also getting a full-blown end-to-end human review tool, right? And once the human moderators have done their decision-making, they have changed the labels and so on, all the data, which is pre-human review as well as post-review, all that metadata is submitted back to you, to your callback endpoints, and then you can integrate it within your in-house system or a third-party system such as this, okay? So let's switch to my laptop here so we can do the demo. I think number 6 is. Okay, so remember we talked about workflows, and I think the workflow is a great place to start, right? So let me open this workflow here, and you will notice if I collapse all, this is nothing but an if-then-else expression, really, that you're mapping out here. If I expand it, you will now see that all I'm doing, the goal of this workflow here was to really generate reviews for all content, just to demonstrate what a workflow, the difference a workflow can make. So in this case, I'm saying use the content moderator API output, right? And use the isMatch output. And if it's equal to true or false, in other words, we create a review regardless what the result is. That's the purpose. Create a review, right? That's the action we are specifying. And then highlight the match tag if the API actually flags it as a match, right? And then, of course, submit the data to my callback endpoint, which is right here. Right now, you don't see any requests, but we'll see requests coming in as we submit the data. And so that's an example of a workflow, right? That's a match. Similarly, for reviews as well, which is the classification scenario, remember. Here, I'm saying if racist score is greater than 0, then create a review, which effectively means anything that we pass through the API, it will create a review because all racist scores, even if very low, will be greater than 0 anyways, right? But again, keeping in mind the same idea that we only highlight those which are actually found to be racy by the API, and that will only happen if the score is actually greater than the internal default or the internal threshold, right? And so that's an idea of a workflow here. Now let me switch back to our code, right? So this is the code, and you will notice these steps exactly match what the scenario we have been talking about, right? And before I run this, let me show you the only difference between the classify image and then the match image is the workflow, right? In this case, I'm calling the match workflow that we just looked at, while for classify, I'm calling the classify workflow. But the code, the other code is exactly the same, right? And so let's run this and see what happens. And so right now it's matching the test data, the content that I have sitting somewhere in my text files against the online links that I've saved. It's also classifying the images and creating reviews. And now it's looking at the text data coming in, right? And so it says done, and go ahead and review online. So the data, if you're curious, the actual ingest data is right here. So these text files, for example, these images, right? So imagine this is your content catalog coming in with URLs to sample images, right? So they are being classified. In this case, I'm actually matching the exact image URLs, these image URLs, with the images that I uploaded previously into the service, right? So you have these hashes of these images sitting, and that's the matching going on there. And so now let's go back to our review tool and click on image. So what you saw was that those images that are setting their links, they were all flagged, or they were all populated inside our review tool as image reviews. Now remember, our workflows, in our workflow we said please create reviews for everything, but only flag or only highlight those content that was flagged by the API. And therefore you see a kind of a larger set here. So these, for example, 1 and 2, these 2 images were tagged as racy. And I can move this zoom bar around and you can see the scores and so on, right? Then these images, the wheel, the tire, and then this part, motor part, as well as this one, I had tagged as something to check the internet for, right? So in this case, they were found as exact matches and got flagged in the review tool, right? And if you wanted to see the text part here, let's go and look at text reviews. And so again, here what was happening was that this line has the confidential product code which wasn't supposed to be online, right? And so that's why this text got matched and the M, which is the match tag, got highlighted. And so what the human moderators are doing at this time is really just submitting and saying, okay, do I agree with the decision or not? If not, well, let's say they can clear the tag and submit their decisions. And let's go ahead and do it to the same as the images. Right? So I can say I agree with these decisions, or maybe what I could do is I can say, well, these are not racies, I'm fine with this, and we submit the next, or click the next button to submit these reviews. And as I'm submitting these reviews, you will notice these requests or the data coming in from our callback endpoints. And this is where your system, your in-house or third-party tool, can take in this data and integrate with the investigation system. Right? So now, if I go back to our workflow tool and very quickly make one change and then run the code again, just to convey what happens now, how workflows work here. And so I'll say content moderator, right? Select is match equals true. And so now the reviews will be created only if a match is found. And similarly, let's do it for image 2. Instead of RACI score, I'll go with the Boolean this time. Now what we're doing is we're cutting down the actual review set, data set, and this is exactly how the actual process works. Now I go back and I run this app again. And there it's, I think it's almost done. So now let's go back and look at our review or image reviews again. And this time you should see only those images that were actually flagged by the API, right? And so that's an example how the workflows very seamlessly work. And with a few lines of code, you can automate the end-to-end process, get out of the box, review tools as well as the APIs, and combine everything. And by the way, everything that I showed here, which is, let me go back, and how do I switch back here? So let me go back. So how do I switch back to the computer, to the presentation here? Oh, well, I did try that, Vijay. Was it coming up?
Which machine are you trying to go to?
The main one, from 6 to the main one, yeah.
Or not.
Okay, good, yeah. So in closing, I guess the only thing I wanted to say was, whoa. Okay, I think this is stuck. All of the functionality that we saw here is exposed through an API and programmable, right? So you're not bound to an actual out-of-the-box tool. Sign up for the service, use the APIs, and extend the product for your own processes. Thanks, Andy.
Thank you so much.
And I think
So it's my great honor and privilege to introduce my friend and collaborator, Pradeep, who is the Chief AI Officer of Symphony AI.
Thank you, Andy. Thanks, everyone. First of all, a huge set of thanks to the Microsoft team who've been incredibly generous to give us the space and time to talk about what we do. So I'm the Chief AI Officer for a new and innovative VC/incubator/fund. We're about $1 billion strong, and founded by Dr. Ramesh Wadhwani, a very prominent entrepreneur in Silicon Valley. We're sort of based in Los Altos. So our goal and approach is to create companies that are at the intersection of enterprise software and the application of AI to transform multiple industries. I mean, as you well know, with all the cool stuff that's coming through from Azure and from Microsoft in terms of the innovations, the application of these technology to specific industries such as healthcare or industrial AI or legal or talent requires a different approach in terms of understanding the lingua franca, understanding the use cases, understanding the personas involved, and creatively bridging the gap between product management, product strategy, data intelligence, and the application software that's associated with it. We are about 8 companies right now, as of now. We started about a year ago, and we are in diverse areas, diverse industries such as healthcare. In particular, our focus is very much on oncology and cancer care. And it behooves me to sort of spend just a few seconds on sort of the healthcare initiative. So we have an exclusive, semi-exclusive. Another company also has a relationship with an organization called CancerLink, which gives us access to the largest longitudinal data sets about cancer patients in the US. The aggregation of that data set, the processing of those data sets for the purposes of determining adverse events, or for recruiting patients to clinical trials, or to think about genomic sequences that are potentially contributors to a disease progression. These are some of the sort of, a small set of use cases. There's a whole bunch of other use cases that we're working on related to healthcare. We are in the retail and the CPG industry, also sort of have pretty rich access to very large data sets associated with point of sale data associated with consumers from loyalty card holder members, especially in the grocery retail chains. So the central theme, so one of the examples that I wanted to talk about, and I'm not going to take up too much of the time here, is one of these applications, which is a complete Azure native application called Symphony Summit. This is in the IT service management and the IT operations management world. So this is the real application. It has a pretty large chunk of the market share over in the APAC domain in Asia. And what we're bringing is a different set of cognitive services and the application of these cognitive services for the purposes of transforming how service management is done, or how operations management is done. So I'm going to demonstrate this with Cindy. Cindy is our vertical bot. It's a bot, and in this particular case, it is Conversational Interface and Decisioning Engine. It's sort of an acronym for what we do. And if you look at sort of like the interactions that are occurring between the end user and Cindy here, hey, I'm attempting to download a report, it's not working. Well, so it looks like you tried downloading these things and suggests that, hey, perhaps is this one of these that you're referring to? And the reference, look at the context in terms of sort of a pretty close to a conversational exchange that you might be having with a service agent, and it essentially attempts to auto-resolve. Now, the key point here, and I'm going to describe sort of like specifically what's occurring here. In order to produce a conversational agent such as this, most of us are engineers here in the room, so we know that this is about the aggregation, assimilation, and the processing of data from a wide variety of systems. In this particular case, we have understood who the specific user is, right? In terms of their identity has been well established, their entitlements have been well established, their recent history in terms of interactions with these reports have been parsed. Well, where does that come from? I mean, it could come from proxy servers or web server logs or other kinds of applications that they've been interacting with. And the fact of the matter is, there's a certain level of correlation and there's a certain level of association that one needs to make about the fact that you're having trouble with this report, and that downloading of the report means one of these potentially hundreds that you run, but in this particular instance, making that classification or association happen is a vertical B2B AI problem. Second is sort of understanding the context of the enterprise. What is this user entitled to? Honoring the security and credentials and entitlements that this specific user was about, taking that into account. And then parsing the fact that, keeping the session context in mind, saying, is this specific thing, is this a thing that you're really after? And then realizing in the backend on the server side that, hey, there appears to be some sort of a problem occurring with this HANA cluster. So what does that mean? Well, we have to look at CMDB, like a topology of all of your network services and things that are occurring there. What might have occurred recently, and trying to determine whether that is actually potentially the reason, correlated or causal sort of effect of what this user is experiencing. And attempting to be helpful in a respectful manner, saying, let me create this report for you on the back end. And at the same time, I'll have this be dispatched to the right service agent that has this particular skill sets involved. So here, what we're talking about is sort of like looking at different network entities, software components, agents, people, and ingesting all of that data and combining that stuff together in terms of building what we call knowledge graphs, and from there arriving at decision making for that purpose. So this is the architecture that we currently have, and this is note the sort of Azure presence everywhere, right? This is a total Azure native application. We are leveraging end-to-end stack of the Azure services. And back to Andy's point, I joined this fund, just a segue. I joined the fund about 7 months ago. Before that, I was at Adobe. The first time I was exposed to the Microsoft and the Azure cognitive services, as well as the entire AML sort of ecosystem, was back when you guys were in the crawl phase, right? Back in 2015, and at Adobe, that journey has been complete, and now we're doubling down on Microsoft and with respect to our both build as well as commercial partnerships. So, just to sort of sum up here, what are we trying to do? Ingest data. So look at the sort of the semantic ontology-driven processing. This is, in general, true for every single vertical that we're involved in, whether it be healthcare, whether it be talent, or whether it be legal, or whether it be retail and CPG environments. The question is to ingest this data set as fast as possible and try to discern meaning out of it, right? And using classic machine learning, deep learning, and reinforcement learning techniques, but also in terms of a focus on the end user persona and the problem that we're attempting to solve and or optimize. Downstream, it's about sort of creating these semantic or vertical knowledge graphs. This is, we think of it as a multi-dimensional graph that is dynamically getting computed based on these data sets. From there, we determine what potentially causal inferencing might look like. And here's sort of, machine reasoning is one that Andy also pointed out to, which is a big area of focus for us from a research and an applied research perspective in terms of knowing that. And as most of you know, in the enterprise world, explainability is kind of a big deal, right? Meaning that why is this thing doing what it is doing, having a certain degree of transparency and being able to explain all that's occurring from a machine learning and an AI perspective so that it receives some level of enterprise acceptance is a big area of focus as well. So it really starts with domain and customer specific sort of like models that are built by ingesting these data sets, by leveraging these machine learning services. So I'm going to end there with basically sort of a high five to saying, given that all of this cool stuff happening, the only thing that's really left, Andy, is flux capacitor.
Oh, that's
time travel.
Very good. Thank you so much.
Thank you so much. We really appreciate your time. Yes.
Thanks again.
Thanks.
The flux capacitor has not been announced in GA as a service in cognitive services. So what is next for cognitive services? I am going to go quickly through this. I'm happy to take any of your questions. You've heard our announcements far and wide over the last 3 days. We are bringing more services to GA. And so things like custom vision is still in paid preview. You can expect a GA from that in the next couple months. We have a brand new unified speech platform that we're really proud of in terms of bringing infrastructures together and having a great SDK. The work that we've been doing in Bing, you heard Ravi talk about Bing Visual Search, and some of the work that we've been doing in bots really is the things that we're very proud of. We're also branching into hardware. You saw Satya talk about the Vision AI Developer Kit. I would be remiss if I didn't talk about the Speech Devices SDK, which allows you to actually take the power of speech and bring that to really dedicated devices. This is very, very slick. I haven't gotten my 6-year-old to convince her to be able to take a look at this yet. But I think the future for us going forward is going from customization, which is tailoring a model to a specific kind of outcome, to personalization, which is tailoring massive amounts of looking at massive amounts of different kinds of targets as opposed to a single kind of domain target. And where you're seeing this, my colleagues who have built Project Personality Chat really warm my heart every time I see this. This is a new service that's in labs that will be coming to the portfolio in the next couple months that allows you to be able to use the power of natural language generation and personalization to be able to generate custom responses and integrate those into a chatbot. So you can imagine here, these are voices or personalities that they've generated for a chatbot that could look like a lot like Cortana, where you have different personalities, whether it's professional or friendly or humorous. And I actually asked them to do me a favor and to generate one based on 10 years of my social media outcomes. And so if you come up to me and say, that's interesting, and I might just say, isn't it? Or if you tell me that I'm so funny, I might be a little bit skeptical and say, thanks, I guess. And these are services that represent the power of personalization, the power of cognitive services working together. Personality Chat can be integrated in a number of different ways, including Q&A Maker, the Azure Bot Framework, which is really stellar, and through their own API, which is coming soon. I want to close today by introducing my friend and colleague, John Langford, who will talk a little bit about how we're going to achieve some of this personalization. And the takeaway here is that it's not necessarily through the same kinds of supervised learning paths that we've gone from before. Thanks, John.
Thank you, Andy. Okay, so I'm telling you something that's a new approach which is happening inside of machine learning. So most of what you've seen is driven by supervised, often deep learning techniques. So in these techniques, what happens is you have a bunch of unlabeled data, like the images over there of digits. You hire somebody to label things. Maybe you get your daughter to label things. I do. Yeah. And then you shove it into a machine, and then out comes a classifier, right? And then people have done great things with supervised learning. And it's amazing to see. When I started out I'm a researcher, right? So when I started out, I had no idea this was going to happen. So it's fantastic to see what's going on. And yet there's another vein of research going on inside the machine learning community, which is around reinforcement learning. And I wanted to tell you what that is and why you want to be thinking about it. So there's a very basic signal which comes up in many different ways. It's kind of a good and bad signal. And you can encounter this many ways in your life, good and bad. And now the key question is, how do you actually learn from a reward signal? Right? So this is what reinforcement learning is really about. So instead of labeling things as a deer or not a deer, you are saying, oh, that's good, or oh, that's bad. Now the question is, why do you want to think about using this more primitive data source? And there's actually a lot of good reasons. So I'm going to give you 5 reasons to be thinking about using this kind of data source. Okay, so first of all, let's go into a little bit more detail about what reinforcement learning is. So in reinforcement learning, what happens is you have some world which gives you an observation. And then based upon this observation, you have a policy which is going to make a decision. So I'm distinguishing from a classifier, which would be typical supervised learning, because we're making a decision which is going to affect the world. It's important that it affect the world. So we're going to make a decision, we're going to choose some action. That goes out and that affects the world in some way. And now you're going to get feedback. You're going to get some sort of reward signal. Oh, that was good, or oh, that was bad. So it's important that you have a policy whose action actually affects the world for this entire approach to work, right? Okay, so suppose we have this kind of setup. Our goal is to maximize the rewards that we receive over time. And now, why do we want to do this, right? So, number one, it's personal. So, is Ukraine interesting to John? This is a pretty difficult question for an editor to answer about me. But it turns out that the answer is yes, because my wife is from Ukraine, right? So, reinforcement learning, by looking at the signals that a user provides, can get at sources of information which are just not available to somebody who's trying to label things. And that allows you to achieve a level of personalization which is not otherwise possible. Okay, so another really important aspect here is that you can actually deal with non-stationarity. Some of the systems that we've worked on do personalized news for MSN. And it turns out that this is an extremely non-stationary problem because there's new articles coming in every hour. The interest level in an article changes over the day, and you would like to be able to adapt to that very rapidly. So typical supervised learning approaches aren't really designed for this kind of thing. It turns out that online learning and reinforcement learning working together are a much more natural solution to this and give you much better, much higher quality solutions. Okay, so another thing that's very cool. So who's familiar with A/B testing? Yeah, just about everybody. Good. Okay, so now here's a trick. It turns out that when you have a reward, which gives you immediate feedback for an action that you take, and you do things in the right way, you can evaluate what would have happened if you had used a different policy, a different way of choosing the action. So this is from real data, hence it's messy. This is the black line here is the actual observed online performance. The teal line behind the back line is the counterfactual estimate of the black line. You can see there's some difference because there's statistical variation. And then this is a recommendation data set. The lower teal line is the performance that the editors had. So it's essentially the supervised performance, where they were trying to create a ranking over news stories. So you can estimate directly. Okay, so this is not an A/B test. That's a kind of a critical thing. It looks like an A/B test because I'm drawing 3 policies up there. There was actually only one policy deployed, which is the black policy. But because of the way we gathered the data and exactly which data we gathered, we can evaluate other policies offline. This is a very powerful trick because you can explore offline many different ways to create policies, many different feature representations, lots of the fun things that data scientists do, instead of trying to explore them in A/B tests. So number 4 is it's free. Right? So if you're trying to, if you can set up these reinforcement feedback loops, typically they're free. Do people click on a news story, right? Or was the outcome from a medical event good or bad? You could start trying to, if you set up these loops, you just start learning. The system keeps getting better and better and better. And we actually observe this in practice. So often what we see is the system, it has some warm-up period, and it gets better and better and better and better, and just keeps getting better over time. So it's very different from the way that a lot of supervised learning approaches work. Okay, and then the last thing is that it's fun. And I'm going to try to, there's a debate going on, I think, in the machine learning community. Right? So the supervised learning approach, AI means a function programmed with data. Right? And you know, that's kind of a fun definition. But I actually think an AI is an agent that explores, learns, and acts. And that's what you're doing when you're doing reinforcement learning. So you're having fun, right? So this is maybe not the motivation you tell your manager. This is the motivation for you finding the other 4 reasons to tell your manager, right? Okay, so Gartner says that reinforcement learning is important. I agree. I knew that. I was coming from a research community where we definitely know that. It's a very hot thing in terms of research right now. Reinforcement learning is behind the Microsoft Custom Decision Service, which you can use to go and customize, personalize even web pages, right? So there's a team of researchers on top and developers on the bottom who've been working on this. There's a lot going on behind the scenes, and maybe some more things will come out sometime soon. But even with what we have, we've been able to do some pretty amazing things. So on MSN, it gave a big lift. With various other external companies, we've had pretty big lifts. So this is a lot of fun stuff, and there's lots more going on. All right.
So thank you. We're almost out of time. I wanted to leave you with a final message. You have many choices in this day and age in terms of what you can use in terms of or things like cognitive services. We are grateful that you have, with all the feedback we have gotten from our developer community, you have made cognitive services better over the last 3 years, and we can't wait to show you what's happening going forward. But if I leave you with one thing, is don't settle. AI is not a one-size-fits-all business. You should insist on AI that meets your specific need, that is enterprise-ready, and takes care of your and your customers' data. And I think there's only one way to be able to take that and make that operational. It's use custom cognitive services. So thanks so much. I'll be up here at the front, and we can talk about and address any of your questions. But thank you so much for participating on a wonderful day, and have a great rest of your build. Thanks again.